Okay, I hear the recording in progress. Okay, so 9.1, I was going to do 9.1 today on Monday, where I already was able to do much of what I needed for 9.1 yesterday, and I should be able to finish 9.1 today. So I'm sort of like a day ahead. Okay, I just have a couple of problems to show you, enough to do all of this. And then I might as well just mark it off because I think I'll be done with all I need. Okay, 1 to 7, I'll skip 6B and 7A is where we're at. Okay, heads up, we're aiming for the test on Friday, the 15th of October. We're October the 1st already. Okay, but notice I would actually get started with some of chapter 10 already. So I will lecture before the test on chapter 10. Chapter 10 will not be on the next exam. It is a chapter 9 exam, but to save time, I'll sneak in a little bit of chapter 10. Okay, our last chapter, chapter 11, as you can see, is fairly long. So we have all this stuff to do. So we'll see how it goes. Okay, so let me talk about the quiz. Okay, so you can get ready for your screenshot or take a picture on your cell phone and whatnot. Try to get that for you up here. Okay, so there we go. So we're verifying the formula for the circumference of a circle. You should know the formula for the circumference of a circle. I've actually already mentioned it. If not, you can look it up. And the way you do it, so find the arc length of x squared plus y squared equals r squared. You should already know that's a circle centered at the origin with a radius of r. So if you have a circle centered at the origin with a radius of r, there's a formula for the circumference. Okay. The hint, they tell us solve for y. That should be very easy. Make it y equals blah, 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 blah. Work in the first quadrant. So you're going to find an arc length in the first quadrant and then just multiply the result by 4. Okay, I'll hold it here just a little bit longer. The problem that's closest to this is problem 2 in section 1, and I'll give you the highlights of that. 9.1 problem number 2. 9.1 problem 2 is the closest to this particular problem. Not 9.1, 8.1. I'm going to show you a little bit about it also. Okay, I will now assume that you've all seen this enough time. Okay, so I'm going to make this disappear. And show you the text. So 8.1 problem 2 on page 548. We did this before. Use the arc length formula to find the length of the curve, y equals blah, blah, blah. This is actually harder than what I'm giving you if you do it the right way. So again, the problem that I gave you, solve for y. That's very easy. You have to do a square root in somewhere. Okay. And I'll give you a little heads up reminder of how that works also. So let me do that for you now. In case you missed it. Oops, that wasn't it. Yeah. Problem 2. So show it to you again. I'm not going to talk much about it. You can almost literally pick this apart and just do the requisite substitutions. Now, in problem 2 from section 8.1, they started off with this. You have to make it look like this. So I went the other way. I squared both sides, get x squared plus y squared equals 2. The quiz, it starts off with x squared plus y squared equals r squared. Bring it back to that. It's very straightforward, hopefully. And that was just a proof of that. So you'll be doing all of this stuff. Find dy dx. You square it. You add 1. The algebra is very similar. And this part is similar. This part is similar. We'll be doing a substitution, which should be very similar. And this inverse sign shows up. I'm practically giving you the answer to a lot of it, but you should see all that. You plug in, and here you get this funny thing. But in our case, the final answer should be the formula for the circumference of a circle, which you all hopefully already know. Okay, so the video that I'm showing you here, everything you need for problem number 2 is everything you need for the quiz. And there we go. Okay, so do 11:59 p.m. tonight. Open book, open notes, open everything. And that is that. Okay, so any quick questions about the quiz before I go on with today's lecture, which will not be that long. I want to give you time to work on that. I'm going to stop the share quickly so I can read the chat if there's anything. Okay, I don't see anything in the chat, so I will go on with lecture. Okay, so back to differential equations. Okay, so differential equations. We're in section 9.1, page 590. We're at the very beginning stages, baby stages of differential equations. Remember, you can take an entire course in differential equations. CSM, that's Math 275. It's the highest course you can take in an undergraduate math level. And the baby stages, so to speak, is just show and tell. Show that blah, blah, blah is a solution. Okay. And we also did number 3, which was our first attempt to try to solve a differential equation. So I did 3, you try 4 on your own. Okay, so I was going to show you 5 and 6, and that's it. Okay, 5 is a little bit different. Okay, if you're not sure how to do 4, work it out like 3. I'll show you 6, by which you can skip B, I think it was. Skip 6B as in boy. Yeah, skip 6B, and also skip 7A. So I'll show you how to do 6. That'll show you how to do 7, hopefully. And then that's about it. Okay, 5. Which of the following functions are solutions of the differential equation y double prime plus y equals sine x? So here are 4 proposed solutions. All they're asking you is plug it in. Does it work or does it not work? Okay, that's just like saying if I solve 3x equals 6. Right? In your mind, you already know x equals 2. Suppose I give a list of solutions. Okay, try 1, try 2, try 3, try 4, right? And you try 1 doesn't work, 2 works, 3 doesn't work, 4 doesn't work, right? That's all that's happening now. Try these proposed solutions and see which ones work, which ones don't work. So here's a differential equation. Again, differential equation means there's an equation, there's an equal sign. Equation, differential equation. So first of all, it's an equation. And then differential means there's one or more derivatives. And there it is, y double prime plus y equals sine x. Okay, so does this work? Does this work? Does this work? Does this work? Okay, so I was going to show you A and D, and then you figure out B and C on your own. I can't do them all for you. Okay, A seems like it's plausible, and there's a sine x there. D looks kind of complicated, negative 1/2 x cosine x. It doesn't seem like it might work, but all we're going to do is try it. Okay, so try this, see if it works. 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 I'll do A and D for you. You do B and C. All right. So y double prime plus y equals sine x. That is the differential equation. So first of all, it's an equation. There's an equal sign. Equation means there's equal side, stuff on the left, stuff on the right. Differential, one or more derivatives, y double prime. All right, so does sine x work? I don't know, just try it. So I need a y double prime. So y prime is cosine x. Y double prime is negative sine x. There's a negative there. That'd be kind of hard to see. Okay, so what's y double prime plus y? It's negative sine x plus sine x. Well, that comes out to be 0. And is that equal to sine x? No, it isn't. So sine of x, as plausible as it might seem, does not satisfy this differential equation. I found a second derivative. I added to the original. I did not get sine x. I ended up with 0. So A is a no. All right, then I was going to show you D, negative 1/2 x cosine x. It looks really, really weird. It seems not to have any relation to the original. And just because I said that, and I've already shown you a no case, that should be enough to kind of tell you that it probably means it's a yes, right? I mean, the most likely scenario you would say was he's going to show us one that's a no, and he's going to show us one that's a yes. Okay, so sine x would seem very plausible. There's a sine x here, but that turns out to be a no. This one, which seems so weird, okay, does it turn out to be a yes? Well, let's try it. Okay, so what do I need to do? I need y double prime, and then I'm plugging in here. All right, so y prime looks like a product rule, right? First function, second function. So do you recall the product rule, right? First function times the derivative of the second, so negative 1/2 x times derivative of the cosine is negative sine x, plus second function, cosine x, times the derivative of the first. What's the derivative of negative 1/2 x? Negative 1/2. Okay, then clean it up a little. This two negatives, so I get 1/2 x sine x minus 1/2 cosine x. So that's my y prime. Okay. And then all I need to do now is find y double prime. So I need to differentiate this guy. So this again is a product rule. First function, second function. So first, 1/2 x times the derivative of the second, derivative of sine x is cosine x, plus the second function, sine x, times the derivative of the first function, derivative of 1/2 x is a 1/2. And then the derivative of negative 1/2 cosine x is positive 1/2 sine x. And clean that up. This is 1/2 sine x. Here's another 1/2 sine x, which is 1 sine x or sine x. So this simplifies to 1/2 x cosine x plus sine x. All right, so there we go. So y double prime plus y, let's try it. So here was the y double prime, 1/2 x cosine x plus sine x, plus y, the original y was negative 1/2 x cosine x, and lo and behold, that cancels that. You do indeed get sine of x. So D is a yes. So one more time, here is a differential equation. Does sine x satisfy the differential equation? No. Does this weird thing, again, right now we're not at the stage of how did you get that, right? We'll never do this in our class. You may develop some techniques of this when you take Math 275, for those of you who have that. But for now, it's just a mystery. You know, where does this come from, right? I don't know. Just try it. It works. So this funny function does satisfy the original differential equation. Y double prime plus y is equal to sine of x. So this one is a yes. So that's all. Okay, so I did A and D. You do something similar for B and C. Right? So again, when I make the requirement that you have to submit at least 70% of the homework, that really is a joke because, you know, I do what, 40%, 50%, 60%. Sometimes I end up doing 75% of the homework anyway. So it's not that big a deal. All right, all we have left are 6 and 7. And then I'm done, folks. So 6 and 7 are somewhat similar. So I'll do 6, you do 7. All right, show that every member of the family of functions y equals ln x plus c over x. Okay, this is a family. It's not just one function, but you put any c for a real number. So c is 0, 1, 2, 3, a million, negative a million, pi, square root of 2 over 2, 3.16521414828. Okay, all of those would satisfy this differential equation. And again, right now you look at this and say, what did you come up with that? Don't worry about it, right? Just do it. Okay, C and D are initial conditions again. That was like what we said over here. All that means is you plug in, if you plug in 1, you get 2. And if you plug in 2, you get 1. Okay, so I'll just do, let me look at my notes. I will only do C. You work out D in a very similar fashion to C. Okay. All right, so 6, y equals ln x plus c over x. Here's the differential equation. How do I know it's a differential equation? Well, it's an equal sign means equation. Differential means there's a derivative, one or more derivatives. And please notice the way they wrote the plus c. We are used to saying, you know, blah, 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 and then plus c hanging out by itself. Not so here. It looks like the plus c is in the numerator, and algebraically, they're not the same thing. Okay, so it's not the same thing as if I go ln x over x and then plus c hanging out by itself. The plus c is part of the numerator. Okay. So this is a family of functions. Again, you know, family of functions means there's infinitely many. Just give me a different value of c. So c can be any real number, 0, pi, negative a million, right? They're all going to work no matter what the value of c is. And again, we're not at the stage of saying, where did you get this weird answer from? Don't worry about it yet. Just plug it in and hopefully it works. All right, so I need y prime. So what's the derivative of this thing? Quotient root, right? So bottom times derivative of the top, 1 over x. Remember, c is a constant. Minus the top, ln x plus c, times the derivative of the bottom, but the derivative of x is just 1, which means you don't really have to write it. All over x squared. Okay, a little bit of cleanup. That's 1 minus ln x minus c all over x squared. So that's my y prime. All right, now I figure out x squared y prime plus xy. So here we go. X squared y prime. So I copy this. X squared y prime plus xy. There's x squared. Here's my y prime. Very conveniently, that x squared cancels that x squared. I'm sure it was me that way. Plus x times the original y. So x times, copy that. Very conveniently, these x's cancel out. So gone, 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 gone. 1 minus ln x minus c plus natural log of x plus c. Well, natural log of x cancels out. C's cancel out. What do you know? It does come out to be 1. It's true. This equation does satisfy the original differential equation. How did they get that is a mystery for now. I don't know where you got it from, but it works. So there it is. It works. And what the problem's finished, but one thing I want you to notice is the type of solution that you get. When we say a solution, the solution looks like a function or a family of functions, a collection of functions, right? This is really a whole collection of functions. Just give me a different c. So ln x plus 2 over x works. Ln x minus a billion over x works. Ln x plus pi over 4 divided by x also works. We've proven it by putting c there in general. Now, in your algebra class, when I said 3x equals 6, give me the solution. You say x equals 2. The solution set is a real number or a set of real numbers, right? For a differential equation, what does a solution look like? A function or a family of functions, a whole bunch of functions. All right. And then letter C. And then I'm finished, folks. So we'll be done very shortly, unless anybody has any question in just a moment. Find a solution of the differential equation that satisfies the initial condition y of 1 equals 2. All right, I plug in 1 for x, I plug in 2 for y, and I just solve for c. And you do the exact same thing for d. Only difference is it looks like they switched the x and y. You plug in x is 2, y is 1, and figure out the c. Okay, y of 1 is equal to 2. If you're uncomfortable with the y of 1, they could have also said f of 1. Okay, so y of 1 is 2, f of 1 is 2 also. And another thing, in case you mix up which is the x and which is the y, when they say y of 1 equals 2, just kind of cover this it. And then it says, oh, y equals 2. So if y equals 2, that must mean x equals 1. All right, so all that means is back in the original equation, put a 1 right here and here, put a 2 here, solve for c. Okay, so y equals ln x plus c all over x. Y is 2. Sometimes I like to cover it up. So if you look at it and say, oh, which one's x, which one's y, just kind of cover this up. It says, oh, y equals 2, which means x equals 1. So 1 goes here, 1 goes here, there it is, 2 goes there. Natural log of 1 is 0. And if you divide by 1, you just forget about it. So c is 2. So final answer for this problem, I found the c, right? So y is ln x plus 2 divided by x. So instead of a whole family of functions, there's just one function, one and only one function, which has two properties. The two properties being this thing satisfies the differential equation. I know it already does because I proved it for any c. So if it works for any c, that means it also works for 2. And then in addition to that, one more condition, when you plug in 1, you get 2. And that throws out all the other functions except for the c being 2. See, when you write it like this, c can be any real number. That's an infinite class of functions. But now, this is just one function that has a property that when you plug in 1, you get 2. Right? You can tell ln 1 is 0 plus 2 divided by 1. You do get indeed 2. Okay. So that's the way that works. And then D as in dog, it's exactly the same thing. So I'll let you work that out. It says y of 2 equals 1. So instead of plugging in 1 for x and 2 for y, just switch it. Plug in 2 for x and 1 for y, do the same thing. I'll go ahead and say that final answer is a little bit not as nice, but it's still possible. Okay. And then what else? You do problem 7 in a similar fashion. So you can skip 7A. So you do B, C, and D. So show and tell. And you try to figure out C. And then D, they give you an initial condition, so it works in a similar fashion. So that means I'm actually done, folks. So we have this. Monday, I'll get started with 9.2. Let me just show you where we're headed. This way. 9.2, there's actually 2 sections. Direction, fields, and Euler's method. That should really be 2 different sections in my opinion, but be that as it may. Starting on page 591. Page 592, direction fields. Stuff looks like that, and like that, and like that, and like that, and like that. We'll be drawing some of these. Okay. So I'll show you how to draw stuff like that, and like that, and like that. So those are direction fields. Sometimes they're called slope fields. And another thing to study is something called Euler's method. It's pronounced Euler, not Euler, but it's a famous mathematician from yesteryear. Euler's method of solving differential equations. Okay, so we'll do that starting next week. Okay. All right, I'm basically done, folks. So let me check the chat and see if there's anything else. Otherwise, I was going to quit, let you get started on the quiz and try to figure out, again, look at problem number 2 from section 1, 8.1. And it's the closest problem to that one. Okay, so any questions, please? Otherwise, I'm going to adjourn the meeting. All right, that's it, folks. So have a good afternoon. Quiz is due at 11:59 p.m. and then have a good weekend. All right, bye, everybody.
Thank you.
Thank you, Professor.
Thank you.